Visual Studio is the integrated development environment for building .NET Framework applications. It includes numerous features that can help you to simplify the development process, from application design to system deployment. If you are familiar with Eclipse or the NetBeans IDE, you'll see that Visual Studio provides comparable functionality, and in many cases it implements features that are only available in other IDEs by installing additional plugins and extensions. Using Visual Studio, you can build a wide range of software, from simple console mode programs through high-performance graphical desktop applications to complex N-tier solutions. Visual Studio is available in a range of editions, with varying levels of support for building, debugging, testing, and deploying enterprise-level solutions. I'll use Visual Studio Express in this demonstration. This is a free version of Visual Studio that you can download from the Microsoft website. It provides many of the productivity features also available in the higher-end editions. Different versions of Visual Studio Express are available for Visual CSharp, Visual Basic, and Visual C++. The best way to show Visual Studio in action is to use it to build some applications. In the first part of this demonstration, I'm going to put together a very basic desktop application by using WPF, incorporating a couple of controls, and then I'll show you how to run this application in the debugger. To create a WPF application, I can use the WPF application template. You can see that Visual Studio Express provides a selection of templates for building desktop applications and class libraries. For the most part, these templates are analogous to those provided with the NetBeans IDE for Java applications. Comparisons with project types available with Eclipse are a little more blurred. Many of the project types available in the Eclipse project wizard are actually similar to items that you can add to an existing project with Visual Studio. Unlike NetBeans and Eclipse, Visual C# Express does not include templates for implementing web applications and web services. However, Visual Web Developer Express does. This is another member of the Visual Studio Express family and is also available for download free of charge from the Microsoft website. Note that the commercial editions of Visual Studio include all the templates provided across the Visual Studio Express range, and you can also implement your own custom templates. I'll create a new project called WPF Demo that I will use to show you how straightforward it is to build and debug a GUI application. The WPF application template generates a window class to which you can add the various controls and other elements required by the application. Visual Studio provides the design view window that you can use to lay out the user interface, and the toolbox contains a wide range of controls that you can place on the window. These controls include common items such as text boxes and buttons, as well as more specialized functionality such as the data grid, which you can use to retrieve and display data from a database. In general, you'll find that Visual Studio provides a highly integrated environment for building GUI applications straight out of the box, and doesn't require that you download and install additional plugins as you might need to do when using Eclipse. The layout of a WPF window is defined by a XAML document. In Visual Studio, the XAML code is displayed under the design view window and is kept synchronized with the GUI layout. When I add controls, you can see the XAML code being updated in the XAML pane. You can set the properties of GUI elements by editing the XAML code, and the design view window will be updated to reflect these changes. You can also set the properties of an element by using the Properties window. The Properties window provides a more guided means of setting property values than simply by typing them in the XAML pane. For example, you can customize the colors of a button by modifying the background and foreground properties in the Brushes section. If you're adding multiple controls to a window, it's easy to align and distribute them by using the guides built into the design view window. If you're designing a complex user interface, you can zoom in and out to display the fine details or get an overall view of the window. Now, This application has a very simple user interface, but it doesn't actually do very much. You can implement the logic for an application by using one of the .NET Framework programming languages. I'm using Visual C# Express, so the language supported by this tool is C#. If you're using one of the commercial editions of Visual Studio, you can also use any of the other available languages, such as Visual Basic, C++, or F#. The code for a window is kept in a separate file, called a code behind file, distinct from the XAML definition. You can see this file and open it from the Solution Explorer window. In this case, the code file is called mainwindow.xaml.cs and is located behind the mainwindow.xaml file. If I open this file, you can see the default boilerplate code generated by the WPF application template. Another small but very handy feature of Visual Studio is the ability to zoom in and out when using the code editor. I just hold the Control button on the keyboard and use the mouse wheel to enlarge or shrink the text. I can generate code stubs that handle the events raised by items in the user interface quite easily. If I return to the Design View window, select the button control, and then click the Events tab in the Properties window, I can see the events that this control supports. I can generate a stub for the click event handler simply by double-clicking the click event. This approach is more straightforward than performing the equivalent tasks in the Eclipse or NetBeans environments, primarily due to the different model that the Java GUIs implement. I can quickly add the code that handles this event. In this case, I'm just going to display a message box that echoes the data that the user typed into the text box in the window. A cool feature of Visual Studio is the various IntelliSense pop-ups that help me to write the code. IntelliSense is like an extended form of the template proposals available in NetBeans or Content Assist in Eclipse. It's context sensitive, so when I start to define a variable, a list of the possible data types appears. You'll see later that IntelliSense is applied extensively throughout Visual Studio and doesn't just apply to C# code. I want to display the contents of the textbox 1 control. When I type textbox 1, IntelliSense displays a list of properties available, and I want to use the text property. Next, I want to call the static show method of the messagebox class to display the data. As I type the dot character after messagebox, the static methods that the messagebox class exposes are listed. When I type an open parenthesis after selecting the show method, I get a list of the overloads that are available. As I provide values for each parameter, IntelliSense narrows the list of overloads displayed to those that match the types I have provided. The context menu in the editor contains some extremely useful functionality. For example, if I right-click the definition of the button 1 click method, select Refactor in the pop-up menu, and then click Rename, I can perform a safe rename of the method. This will not only change the name of the method, but will find all references to the method throughout the application and update them accordingly. At first glance, it appears that the refactor commands available in Visual Studio are limited in comparison to the corresponding functionality in the Eclipse and NetBeans code editors. However, don't be fooled. Visual Studio employs a context-sensitive menu system and only displays the items that are applicable in a given context, resulting in a smaller and more easily navigable set of options. You'll see examples later in this demonstration where additional refactoring options become available. The Find All References command enables you to quickly locate all references to a symbol so you can assess the likely impact of changing the name of an item before you actually change it. For example, I can see that the display message method is actually referenced by some of the code generated by the WPF application template. This is the code that connects the event handler method to the button and was generated when I created the event handler earlier. Note that while it's interesting to look at this generated code, I shouldn't attempt to modify it myself as it's managed and maintained by Visual Studio. A related feature is Go to Definition. If I right-click an item and select Go to Definition, I am taken to the point in the code where that item is defined. The item could be a variable, a type, a method, or some other item. For example, I can quickly locate the definition of the display message method by using this technique. Go to Definition also works for types that you've imported from other assemblies, even if you don't have the source code available. As an example, I can quickly see the definition of the messagebox.show method. Visual Studio extracts the definition of the show method from the metadata in the presentation framework assembly that contains the messagebox class. You can't actually see the code for the show method, but you can view the documentation provided with each overload. Other useful features include the ability to tidy up the using statements in a code file, and a utility that can refactor code into a block construct, such as a do loop, an if statement, or a class. I'll use the surround with feature to wrap the code in the display message method to only display the message if the user has actually typed something into the text box 1 field in the window. These code refactorings are achieved by using code snippets provided with Visual Studio. And you can extend this feature by adding your own custom code snippets. Yet another feature is the block select capability of the code editor. Normally, if I use the mouse to select a block of code, the editor selects the code based on lines of text, as you can see here. This is the way text editors and word processors tend to work. However, code isn't ordinary text, and sometimes you want to select and copy a rectangular block of text. For example, I'd simply like to grab the list of namespaces referenced by my application without the using keyword, so I can copy them into a comment. If I press the Alt and Shift keys, now when I highlight text, it's selected based on the area that I highlight. I can then copy and paste this text, and only the highlighted text is copied. You might find yourself sometimes switching back and forth between the design view window and the code editor. To help save you some time and make you more productive, Visual Studio includes support for multiple monitors. You can click and drag a Visual Studio window and position it on another monitor if you have one available, or you can just position it to one side of Visual Studio and use the Windows 7 Snap feature if you only have a single screen. You can now work on the code and the window layout and see both at the same time. You can also drag the window back into the Visual Studio IDE if you need to redock it. Naturally, a primary function of an IDE such as Eclipse or NetBeans is to provide an environment for debugging applications. Visual Studio implements an excellent range of easy-to-use debugging features. You can set a breakpoint in your code by clicking in the left margin in the code editor. When you run an application in debug mode, it executes as normal until it reaches the breakpoint. For example, in my application, if I enter some text and then click the button, I should hit the breakpoint I've just set at the start of the display message method. I can then examine the value of any variables by hovering over them in the editor, using the locals window, or by entering an expression in the immediate window. Notice that IntelliSense applies, even at runtime. I can single step through code. Notice that as I advance through the code, the debugger highlights the next statement to be executed. As variables come into scope, they appear in the locals window, and I can see how the values of variables change as I step through the code. I can continue running normally simply by selecting the Continue option on the debug menu. The code will carry on executing until it hits another breakpoint. If you're building a commercial application, you might wish to employ the skills of a specialist GUI expert to design your windows. However, although such experts tend to be skilled in graphics design, they might not be quite so familiar with the coding involved for implementing the logic of a complex system. The way in which WPF structures applications enables a GUI designer to generate the XAML description of a window, while a programmer can then add the code to implement this logic. To support this mode of working, and really improve the developer-designer collaboration workflow, Visual Studio can be used in conjunction with another tool called Microsoft Expression Studio. Expression Studio enables the designer to build the professional layout, and the XAML code that the tool generates can be imported into a Visual Studio project. You can find out more about Expression Studio on the Microsoft website. What I've shown you so far gives you a flavour of the capabilities of Visual Studio, but now I'm going to build another, more real-world application for querying and maintaining order information in the AdventureWorks example database provided by Microsoft. To do this, I'm going to use WPF and the Entity Framework. Visual Studio provides tools and templates that can help me get an initial application up and running very quickly indeed. The first thing I need to do is to build an entity model for retrieving the order information from the AdventureWorks database. I can do this by using the Add New Item wizard. As mentioned earlier, notice that the items that I can add to a project include many that are similar to those available in Eclipse through the New Project wizard. To help me do this, Visual Studio provides the ADO.NET Entity Data Model Wizard. The Data Model Wizard prompts me for information about which database to connect to. And which tables I want to access. In this case, the Sales Order Header and Sales Order Detail tables. It then generates a series of entity classes that I can use to fetch and update this data. The Entity Framework implements a model that is functionally equivalent to that available through JPA and Hibernate for Java applications. The design window, wizards and templates provided with Visual Studio make constructing, maintaining and using an entity model very simple. NetBeans provides similar functionality, as does Eclipse if you have the appropriate plugins configured. However, the Visual Studio wizards are arguably more intuitive and provide better guidance for a new developer needing to get up to speed quickly. Note that in this example, I've adopted a database-first approach and have derived the entity model from the database. The Entity Framework also enables me to follow a model-first approach and use the Entity Model Designer to build an entity model from scratch and use this model to generate a database schema. The toolbox contains a simple set of tools for creating entities and relationships, and the Mapping Details window lets me specify how to map properties in an entity to columns in a database table. This is an extremely powerful feature that enables me to remodel my entities graphically. If you're familiar with NetBeans or Eclipse, you have probably had to resort to third-party extensions or manually update the code for the entity classes to perform the equivalent tasks. The Entity Model Wizard generates a set of classes that an application can use for connecting to the database at runtime and then retrieving the data defined by the entity model. This code is generated by using a template. Although you shouldn't change this code directly, as it'll be updated and your change is lost should you modify the model, you can define your own custom templates if you require specific boilerplate functionality. Additionally, the code generated for the entity model comprises a set of partial classes which you can easily extend. The database connection information is stored in a separate configuration file. Application configuration files are XML files deployed with an application, and they can contain a wide variety of configuration data. For example, if you're building a web service, the configuration file can contain security information describing how to authenticate users. Using a configuration file enables an administrator to update some aspect of an application, such as changing the server that it connects to, without requiring that the code is modified. As an aside, you should note that, like the Code View window, the Application Configuration File Editor supports IntelliSense, helping to ensure that your configuration file conforms to the appropriate XML schema. You can view the list of predefined XML schemas provided with Visual Studio, and if you're implementing your own custom XML structure, you can also add your own schemas. Now that I've built the entity model, I can turn my attention to the user interface. To keep things simple, I'm going to get Visual Studio to generate a default layout for me. When I've completed the coding, a graphics expert can then design a more professional layout using Expression Studio, and I can then slot it into my application, replacing my initial UI. First, I need to make the window a little larger. I can set the height and width properties either in the Properties window or by modifying the XAML code. The Data Sources tab provides me with a means of defining a default layout for the entities in the Entity model. I'll display the information in the Sales Order Headers entity as a list view, and the Sales Order Details as a data grid. Notice that I can also tailor the way in which individual properties from an entity are presented. For example, the various date properties in both data sources are displayed as date picker controls, while most of the other properties default to text boxes. If I don't want to include a property when I add a data source to a window, I can set its default layout to none. I'll do this for a number of the items in the Sales Order Headers and Sales Order Details data sources. Also, I don't want the user to be able to change the various ID columns, so I'll display them as read-only labels. Now I can drag and drop the Sales Order Headers data source onto the window. Visual Studio will generate a default layout based on the styles that I specified. To display the details for each order, I can drag and drop the Sales Order Details property of the Sales Order Headers data source onto the window. If I look at the XAML pane, I can see the extensive layout code generated by Visual Studio. The data is displayed in two grid controls which group the various user interface elements together. This code also includes data binding elements that retrieve the data from the database by using the entity model, connecting by using the connection information defined in the application configuration file. The data bindings also ensure that the data displayed in the two grids is kept synchronized. Visual Studio has also generated a little code to retrieve the data for the first sales order header when the application starts up and displays the window. You can see this code in the CSharp file behind the main window definition. When I run the application, the window loaded event handler retrieves the data, and the data binding for the WPF controls causes it to be displayed. As I scroll through the list of orders, the details for each order are shown. To verify that the correct data is being displayed, I can query the AdventureWorks database directly from Visual Studio by using Database Explorer. I can then compare this data to that shown by my application if I want. This is a pretty neat application, and I haven't had to write any code myself so far, but all it does is fetch and display data. If I want to create, insert or delete information, I need to add some of my own code. The Entity Framework provides a powerful set of APIs for doing this, but the details are really outside the scope of this demonstration. Instead, I want to show you some of the additional features that Visual Studio provides to help you write and test your code, whether it involves the Entity Framework or some other set of APIs. For example, suppose I wanted to abstract the details for creating, updating and deleting objects. I might choose to do this by defining an interface and then creating various implementations of this interface that provide the specifics for interacting with a particular data store. Visual Studio provides templates and wizards that can assist me. I'll start by adding an interface to the AdventureWorks project. I'll call this interface iAdventureWorks CRUD for Create, Update and Delete. And I'll define operations for creating, updating and deleting sales order detail entities. While I'm at it, I'll also tidy things up and remove any unnecessary using statements that were included in the template. The next step is to create a class that implements this interface. I'll call this class AdventureWorks CRUD. I need to specify which interface this class implements. Again, notice how IntelliSense kicks in and I can quickly select the correct interface. I can then get Visual Studio to generate method stubs for each of the operations specified by the interface. I'll provide a bit of sample code for the create sales order details method, but for the other methods I'll just return true, and you can pretend that I've added the code to update and delete sales order details. However, to make sure that I don't forget to implement these methods properly later, I'll add some to-do comments. These comments are handy because they appear in the task list, providing a précis of any outstanding work to be performed by the developer. NetBeans provides a similar feature. Incidentally, another great feature of Visual Studio is the Object Browser. The Object Browser lets me examine the contents of assemblies referenced by my application. Here I'm using the Object Browser to examine the entity object type. This is the base class that the sales order detail type extends. Returning to my class, the code that I've added, or I will add later, will create, update and delete entities. But I also need to add some code to save the changes to the database. I'll add some appropriate logic to the create sales order details method. The details of this code are not important, but what it does is to add the new sales order detail to the sales order details collection implemented by the entity framework, and then call the save changes method to store this new object to the database. If some sort of exception occurs, the catch handler will trap it and attempt to resolve it, once it's been written of course. You might notice that Visual Studio tags the reference to the MessageBox class as an unknown type in the current context. This is because the namespace holding this class should be added to the list of using statements at the top of the file. I can quickly add it in by using the resolve command. This looks promising, but the code that actually saves the changes and handles any errors is also going to be common to the update sales order details and delete sales order details methods. Therefore, it makes sense to factor it out into a separate method. This is easy. All I need to do is to select the code, right-click, and then use the Extract Method wizard. Notice that this wizard intelligently works out that it depends on the AdventureWorks entities variable and generates an appropriate parameter for the save details method. Visual Studio can also generate stubs for methods that you have yet to implement. You simply write the code that calls the method, passing any parameters, and then invoke the Generate Method stub wizard. As before, this wizard looks at the context of the method call and generates the appropriate parameters and return value. Finally, to verify that my code is working correctly, I can quickly add some code to test the save details method. If you're using one of the commercial versions of Visual Studio, you can generate tests automatically, but with the Express editions I need to write some code myself. I'll add a button to the main window and generate an event handler that runs when I click this button. In the event handler, I'll call the create sales order detail method and update the display, just so that I can verify that the new record has been saved correctly to the database. When I run the code, when I click the test button, a new sales order detail record is generated and saved to the database. I can see it at the bottom of the list. In conclusion, Visual Studio provides the ideal environment for developing application code by using the .NET framework. This demonstration has only shown a few of the time-saving features available, but Visual Studio includes numerous other items that can help to improve your productivity. All of these features are provided as standard without the need to download and configure additional tools and packages. The commercial versions of Visual Studio include many further enterprise-level features, such as the ability to generate test cases and profile your code. Visual Studio is also highly extensible, and you can incorporate a wide range of additional utilities available in the online Visual Studio Gallery hosted by Microsoft.